let's talk about that.
Alright.
Remember, A is the what for the equation?
The concave up and concave down.
It defines the concavity, right?
Mm-hmm.
But remember, when you have standard form, how do we write standard form?
AX plus
AX squared.
plus BX plus C.
So remember, A, is that the x squared?
No.
It's just what's in front of the x squared. What number is understood to be in front of that x squared? Alright, I know that we're not quite done, but we do need to go ahead and get started, so I'm going to collect, which I believe I need to change. Yeah. Okay, so let's look at these answers. Speaking honestly, how much time do you think you spend learning Algebra 2 stats on a typical day, a typical week? So, 0 time, 15 to 20 minutes, 1 day each week. 20 minutes weekly or daily? Anybody want to say if that was them? No? Okay. Not gonna lie to you, none. About 10 minutes every other day. I don't even touch my backpack when I get home. I just do homework a day before. Or of if it is due on a typical day, 5 to 7 minutes, and it's typical week, 25 to 30 minutes. Wait, typical week, probably 25 to 30 minutes a day? Maybe 25 to 30 minutes a week then? So, I feel like I may know who the second to last person was, because he might have mentioned it earlier, but other than that, I don't know. So there are a couple of these that I think would be enough time, but this is just something I want you to think about. Like realistically, is that enough time to learn this math well?
I
Right?
mean, not well, it just gets me by.
But, and this is the challenge I want to leave with y'all, and I want you to think about, if you're going to do something, do it well. If you're going to do something, do it well. Take pride in your work. All of you are capable of doing more. That's the challenge I want to leave with you. Okay? I know that sometimes we're okay with where we are, but I want to challenge you to not be okay with mediocrity. I want to challenge you to seek after greatness. Because I know that all of you are capable of more. Goal shouldn't be to pass a class. Your goal should be to learn it. Your goal is just to pass a class, that's it?
Yeah.
So I want to clarify, like if your goal is just to pass a class, what grade should you be looking at for that class?
Let's see.
An A is not passing a class.
Let's see.
A C, I think, would be pretty good passing a class, but realistically, mid to high D, low C is passing a class. Like, that's something to be aware of.
A 65 is passing.
I mean, technically in this school, it's 61 or 60 even.
Mm-hmm.
When I grew up, 64 was passing. We're on a 9-point system, so 91 to 100 was an A, 82 to 90 was a B, stuff like that. But again, I want y'all to understand, like, you're capable of more. I know you're capable of more. So expect more out of yourselves. Also, I would challenge you, if you don't even know what the different equations are, like you can't write them out, you don't know what the different values in the equation mean, how's it going to go with you when you're given an equation? You have to identify the different features of that equation. Probably not well. How about when you're supposed to write a certain form of the equation? How's it going to go for you? Not very well. You got to sit down and you got to know your equations. Take the time to study them. The more times you write it out, the better off you're going to be. Make flashcards. Do something to make sure that you know your equations. Maybe you look over, write them down on flashcards, and you look at one side that says factored form, and you say the factored form out loud, and then you check the back to see if it's right. Or you give yourself the equation, and you have to name which form you're looking at. You write down factored form and you have to identify the different features that you can identify from factored form. Because I'll go ahead and tell you this, can you identify the x-intercepts right away from factored form? Nope. So on the understanding check on Monday, should you have ever written down an x-intercept when you had the factored form? No. What are the only features you should have identified if you have the factored form, or the vertex form?
Vertex or factor?
Sorry, vertex, what I meant to say.
Vertex.
The vertex, right? Like, if you have vertex form, it's in the name, it's a vertex. What's the other thing you could have identified from vertex form? A, but remember the A is defining what? The concavity, right? The H is defining your axis of symmetry. And so these are things you gotta study, you gotta know. This is why we need to take a little bit more time probably to study some. And I will say this, some of us can be here and still find massive amounts of success. Some of us can be here and find massive amounts of success. When I was in high school, I lived here in math and science. I lived there, like straight up. I did the homework, I was good to go. But I will say, when I did the homework, I looked at my notes, which was how I studied. I used my notes to help me do those problems, to make sure I was doing them right. Look at your notes. When I got to college, I had to live more in at least this region to this region for each of my classes. Because, well, it was tougher. I had to learn how to study more. Because I didn't have to do that, I was able to just do the homework. I was not in high school. In college, that was not the case. I care about you and I care about your future, which is why I'm trying to get you to see a better way to be more successful. And the better you learn it early on, the better off you'll be later on. So we had a couple of questions, write an equation for the function to the left. Does anyone see anything that I want us to be careful about when writing this equation? Okay, so first off, definitely we need a y equals, or what else can we write? F of x. Okay, anything else that we see up here that we need to be careful of? Right, similar thing here. I see 6 times negative 2x and 2x times 6. Do all of those things need to be multiplied? Nope. What are the equations that we have studied for a line, the two options? Notice what needs to be happening between the rate of change, which is multiplied by the variable, and the y-intercept. They are added. Because what type of rate of change does a linear function have? An additive rate of change, right? And once again, how do we show repeated addition? That multiplication right there. Those are things we want to pay attention to. What was the other version that you like to use, Lexi?
Y equals A plus bx.
And either is perfectly fine. Again, I like this one honestly because it shows me my y-intercept where I'm starting, and then I'm repeatedly adding my slope to it x number of times. Either one is fine, but once again, and this is exactly what I would say when it comes to the quadratic equations, you gotta know these different equations. If you don't know the equation, it's really hard to substitute the correct values in. So, as of right now, there are 5 equations you gotta know. What are the 5 equations? Factored form of a quadratic equation, vertex form of a quadratic equation, standard form of a quadratic equation, exponential function, and the linear, which is the slope intercept form, right? So you got to know those different forms. If you don't know them, this test that we have next week will be a rough time. We're a week out from the test, not even quite a week. We got to know this stuff. Huh? We've only studied, there's the 3 quadratics, a linear, and an exponential. Now you could consider this 2 different ones. I wasn't considering these 2 different ones. They're both slope intercept.
I thought quadratic was
We had standard, vertex, and factor. We will learn one more equation today actually, but it's not a form of a quadratic equation. It's to solve a quadratic equation. We'll talk about the quadratic formula. I will point out, I do like this right here. -2 divided by 1 what should that, why is that there? Why should that make a lot of sense?
I mean, it's what you do.
It's what? It's the slope, it is what we do.
Yeah, I just.
It's what? Rise divided by run, right? Change in y divided by change in x, right? Writing the whole slope out there. Even though it's divided by 1, it is good to note that it is divided by 1. Is that equivalent to what we see up here and down here? Yes, right? Perfectly acceptable. Just be, oh, and then here as well. Just be careful right here, -2 times x plus 6. Any questions before we move forward on writing these equations? Do we address some misconceptions? Do we understand how to do it a little bit better?
Yeah.
I'm confused.
We'll get to the book stuff soon. Okay. Alright, so the second question is, you have the equation -x squared plus 6x minus 8 equals -1. Why can you not solve this equation using the factored form of a quadratic equation to solve this equation, right? It's not equal to 0, right? Plainly put, if we're going to use a factored form, the first thing we got to recognize is it needs to equal what? 0. Because what property are we going to use there? 0, product property. Remember, the factored form, what is factored form? A. And so when I set that equal to 0, if I multiply anything time, or what's the only way that I get a 0? If I'm multiplying by what? 0. Sorry, I said that wrong at first, but the only way to get a 0 over here is if I'm multiplying by 0. Well, any other factors, there's lots of ways that it could work out, right? So we want it equal to 0, so we have that 0 product property. And so I see most of us talk about it's not equal to 0 on the right-hand side. And the decimal doesn't repeat or terminate. What do you think they're referring to when we say the decimal doesn't repeat or terminate?
That thing, that, what's it called? It's a what number?
An irrational number, right? The decimal doesn't terminate, it doesn't repeat, it's an irrational number. But what are they referring to if we're talking about a factored form here? The x-intercepts, right? If we're going to write factored form, we have to have x-intercepts, and we would want to check that. And if you go to documents, one thing I do want to clarify is, if you look at your calculator, you don't have to add another page to do graphing and calculations. If you hit this button, it goes to what's called a scratch pad, which gives you a calculation page. You hit it again, it gives you a graphs page, right? So you don't have to add a whole new document to do a graph like that. Just use your scratch pad, and then you hit escape to get out of it. So let's see if I can actually...
And you gotta do the graph entry thing.
Right, so notice it gives you, and it even says scratch pad at the top. I click it again, and there's the equation part. Right? And to get out of it, you just hit escape. But I should have -x squared plus 6x minus 7 once I get it equal to 0. And especially for those of us who missed yesterday, you need to pay attention to this. How are we going to find the roots, the zeros of this equation? Because it's definitely not perfectly on a 1 or a 2 or a 3.
Oh, on the menu.
Menu.
And then you do analyze.
And we're analyzing our graph, and we want zeros.
And then you put the point in the space area.
Okay? And so you can see it just with the first one. And I will point this out, if you haven't noticed this, what you can do is the cursor that allows you to move the stuff around, if you end up holding it down, it'll actually grab stuff. So if you look, my hand is open now, I hold it down and I can move this so it's easier to see things. But that's what we're talking about right there. Do you think those decimals actually in there, or are they probably going to keep going for forever? Keep going for forever. We can't find them. So we can't use a factored form, but what form could I potentially use? Vertex form, right? Now, do I have to be equal to 0 to use vertex form? No, but I've already got it, so I might as well just leave it as it is, right? So I don't have to have vertex form. Okay, so how am I going to get my vertex though? Analyze. Grayson, don't fall asleep on me. And that's a maximum, right? So I'm going to find that vertex with a maximum. Ah, man, that is really nice. 3 comma 2. The x-intercepts, can we all agree that those sucked? Yep. But the vertex, is that nice? So what is the vertex form that I am trying to get to? A I need y'all to pay attention to this because I saw a lot of students already while checking, going over the understanding checks. If you don't have a square, is that a quadratic? No. Gotta have that square there. Because remember when we do x minus r1 times x minus r2, when I do x times x, what do I get? X squared. Okay? Gotta have a square somewhere in there. So what is my a? Okay. Remember how, and you have to recognize your standard form, a is just the coefficient. No, there's no number there, but there is a negative, so it's understood to be negative 1 times x minus 3
Square.
plus 2 is equal to 0. Alright. I want you to pay attention to this right here, because once again, I'm seeing students make mistakes on when it's supposed to be a positive versus a negative right here. If you write this equation, and all you do is you put that 3 in for h, will you mess up whether it's supposed to be a positive or a negative?
Yes.
If you already have the equation written, and all you do is you substitute that 3 in for h, that's it,
Oh, no.
will you mess up that positive versus negative?
No.
So, make sure you know your equation, take the maybe 5 seconds to write out that generalized equation first, and then substitute your values in. Yes, you can memorize whether it's supposed to change signs or not, but that's a dangerous way to miss points when you don't have to. Okay? Now that I have it in vertex form, all I'm going to do is solve it like normal. KJ, what could I do? And I want to clarify, there's several things I could do. What could I do from here to solve that equation? By the way, if I was typing this in the calculator, that would be my step 2. Right, so step 1 was getting it equal to 0, step 2 is getting that vertex form. Any idea what I could do to solve this equation now? None? Well, remember, I don't want all of this stuff here, so what could I get rid of? KJ, what could I do to this 2 to get rid of it? That Lexi was talking about. Right? All I need to do is recognize where I can create a 0 or a 1. Minus 2. That's a 0. I've gotten rid of some of this stuff on the left-hand side. I just have to do it to the right-hand side to make sure it stays equivalent. Okay? Jelani, what could I do next to solve this equation?
Plus 2.
So remember, we just subtracted the 2 to get rid of that, because I'm trying to get to this x here, right? So I want it as this negative 2 right there. Any other ideas?
Plus 3.
So that's a good idea. Can anyone explain to us why we can't add 3 yet, though?
Square.
It's inside the parentheses and it's being squared, right? So I would have to square or undo that square before I can add 3. Does that make sense? So remember, y'all, a basic principle is start with your x, identify what's then happening to the x. Subtracting 3. After I subtract 3, what am I doing? Well, squaring it right now. Which if I want to, I could distribute, but don't distribute. Use your inverses. After I square all that, what am I doing?
Could you take the square root right now?
Yes and no. It will make your life harder. So, but notice, we're squaring. Is there anything else happening after the square? Huh? Yo, x, then minus 3. Then squared. Have I taken care of everything on the left-hand side?
Plus, did you do that?
Can I add 1?
Yeah, you did. You could do plus 2 to get 0. No.
Remember, the whole point was to make that a 0 so I could solve.
We have to add 1 to get the x minus 3 squared by itself. And then we have to add it on both sides.
I wouldn't add 1.
Divide,
Why would I divide?
because it's multiplied.
Remember, it's being multiplied. Addition takes care of subtraction. I'm multiplying here, so I'm going to divide by negative 1. So x minus 3 squared is now equal to dividing, y'all, you have calculators, what's negative 2 divided by negative 1? 2.
2
Okay, thank you.
and squared.
Now what?
Take the square root.
Now I can take the square root to undo that square. So x minus 3 is equal to what? Oops. You need to be careful here. A lot of students will forget an important detail at this point.
Then I'll do it first.
So I'm going to come back to what you said in a second. What did you say?
Couldn't leave it as the positive, negative thing.
Okay, so we can leave it as the positive, negative. So we need to remember, whenever we take that square root, we got to do plus or minus. And what did you say? I can just leave it like that. So be careful, Lexi, because what you said was 1, right? But it,
I was talking about something different.
okay,
I was saying, because we used to like, the 2, we put before. Like, not that 2, the small 2. No, right?
oh, the square.
Yeah.
Oh, you're saying an exponent of 1? Yes. Yeah.
Can't you put, okay, do it matter if you leave it like that, or you do this?
So I mean, you don't have, I mean, I would leave it like this.
Like on the T.
If I get a square root that's not a perfect square, I would leave it like this. So like, if you get a square root of 9,
I'm trying to see if you can.
what is the square root of 9? 3.
Yeah.
That's a rational number. Square root of 2 though, do you know what that is?
1.4.
1.4 something, but like, because it's getting that decimal, it's an irrational number. Will that decimal ever stop? Nope. Will it ever repeat? No. So, just leave it as square root of 2. Right? So if it's not a perfect square, just leave it as that square root. Simple. Okay? Then, what would I finally do? Add 3. Yeah? And so you can write it a couple of ways. You can write it as x equals plus or minus square root of 2 plus 3. Traditionally, people like to write it as 3 plus or minus the square root of 2. We typically put the radicals afterwards. Okay? Just be aware of that.
So we only need to write one of them, not both.
On the calculator? What do you mean?
Like, do we write both of those equations, or just one?
Oh, just one of these. Notice I was saying that you can either put the radical first and then the plus 3, or the positive 3 and then the radical. This is what's traditional. And so I would go with that. And you'll see part of that reason why either today or tomorrow. Okay? Any questions at this point before we move forward? Okay? So, this is why we solved equations early on in the year. You've got to recognize properties of equality and also which inverses to use. This is why I've told you, and I'll keep telling you this. Start with your variable and work from the inside out. The last operation being done is the first one you want to undo. If I start from here, what's the first thing happening to x? Subtracting 3. Then what are we doing? Squaring it. Then what are we doing? Not plus 2 after that. Remember, multiplication happens before addition, right? So we're multiplying by negative 1, and then what's the last operation being done? Adding 2. What was the first operation we undid? That plus 2. The last operation being applied to your variable is the first one you want to undo. That is a very, very, very important detail that you should pay attention to. Okay. If anybody has homework to turn in, get it out and I'll take it up as we're working on this. But we're going to try to finish up lesson 5, the root of the problem, solving quadratic equations. Before we start lesson 6, I want to believe.
I'm so confused. I get home and it's like I thought I understood what was happening in class, and then it's like the homework is doing something totally different.
I will challenge you to say that
And
it's
then I end up
not
just
doing
having to
anything.
go on the internet and like have an old man like do it piece by piece, and then I copy it, and then I don't even understand where he got the numbers from, so I'm like confused.
So instead of going online, I might go to YouTube. By the way, it's super simple. If you haven't done this before, and when I say YouTube, what I mean is YouTube, which I meant to bring this up anyways, man, struggling to type today. Any guesses what you could type in to find the videos that I've uploaded that deal with the exact same problems? You can literally search here, Nathan Kinney.
We found like
Anybody see which one is mine?
He's like
The
murder
one with your
charges.
wife.
The one with me and my wife, the second one there, with how many videos? 403 videos between last year and this year. Okay, that is not all this year. Okay, and then I will say I would go to playlist. Any guesses which playlist you should go to? Kenny's algebra 2 stats, right? Now, it'll automatically, for some reason, is there a way to just access the playlist? Oh yeah,
It's on the
view
side.
full playlist here. And so if you go to the playlist, you can sort it. Notice it's starting at the very beginning of the year. You can go from date added newest, and there it is, October 26th, 25th, 22nd, 22nd. I titled it to help you identify what things we were talking about. The thing that takes me the most time though is if you click on it, and you go here to show more, I have time-stamped every single piece. The first part of this video is us going over how to solve two different quadratic equations that were given as bell ringers. 7:30 to 10:45. This is also a part of the bell ringer questions, focused on writing the equation of a function given graphically. If you know that you are struggling with this skill, go to that part of the video. You don't need to watch the rest of it, but I've given you the details to be successful. Okay? Specific problems straight from the book. Upload those every single day. Or at least I try to every single day. If I forget one day, email me and I'll make sure I get it up ASAP. So, we're going to finish up lesson 5. Ooh, I just realized I didn't actually copy something over. Hold on. Because we didn't finish 5.2 yesterday, did we? No? Alright, let me add that in. So, we're trying to use graphs to determine the roots of quadratic equations, rewriting quadratic functions in forms that reveal the key characteristics, and to factor those quadratic trinomials. By the way, trinomials. Why do you think I'm calling something a trinomial?
Three numbers.
3 numbers, right? The standard form is what I'm referring to when I talk about a trinomial. Okay? Use graphs to rewrite quadratic equations of the form ax squared plus bx plus c in vertex form. That's what we did in the bell ringer because we couldn't do factored form. And we get into the quadratic formula today. So, we did this yesterday. Again, I will point out, and I said this yesterday as well, the book has you doing this in what way? Not graphically, but algebraically. Am I going to ask you to do it algebraically? No. Graph it, find your A, find your vertex, and just solve the equation from there. Don't make it harder than it has to be. Yesterday, I believe we wrote each of these in vertex form, correct? Wasn't that the last thing we did yesterday in class? The next page, bud.
I'm confused on
No. He was on the right spot. Yeah.
What
Yeah.
page?
Right here.
Okay.
Oh, the square root.
Okay.
We have to, do you do the square root for, like, if they, I thought you have to simplify it together.
We never did number 4.
I know, but I
Okay.
still was just, I thought you had to simplify it together, like I thought
We
4,
didn't
you
do
have to
these.
find what 4 and 25 had in common, so I thought
No.
we just stopped.
We
there.
didn't do any of that, but square root of 25 is 5. Square root of 4 is 4.
Yeah, but. I
We'll
mean,
talk about that at one point though.
putting it together.
Okay, so really quickly, what was the vertex form for number 1?
We didn't do B.
Okay, part A. What was the vertex form we got?
1 parentheses x minus 3 squared minus 5 equals 0.
Right? That's just like the bell ringer once you get the vertex form. Now, did we work at all on the vertex form for part B?
Yeah,
We did get the vertex form, we just didn't finish solving it?
we
No.
finished solving it.
Well, I mean,
Right, but
I
B.
didn't write it.
We didn't do B at all?
No.
Okay, let's try to take 5 minutes within our small groups. Work on B, we'll go over it, and then we'll move to 5.3 after that.
Oh, no, no.
Okay? So, let's get to work on part B, especially if you weren't here yesterday, there's only one of me, so what do you need to do? Work with your small group, okay?
Where did minus 5 come from? Where? It's not in the equation.
It's on the graph right
Oh, okay. Oh, yeah, I forgot.